and you should get something like 1.2% or 0.027% for the first one. Okay. So what would this be? So when your Km is much, much, much greater than your S, you're at this part of the graph, right? This is when your velocity is still linear, right? But what you're going to have to do is you're going to have to integrate this to find out what's under here. Okay. Because Km is so much greater than S, S down here is going to go to 0, and you're going to be left with V equals V max S divided by Km. Velocity is equal to dp over dt, or it's also equal to negative ds over dt. So it's either equal to the appearance of product or the disappearance of substrate. That's just its definition. So now I'm going to plug in negative ds because this isn't in terms of product, this is in terms of substrate. dt is going to equal V max S divided by dt, or I'm sorry, Km. What we're going to do is now we're going to take our S, divide it, and take our T times it. So now it's going to be negative, I'm actually going to take this negative over with the dt. So I'm going to multiply by negative dt. So now I'm going to have ds divided by s equals negative V max Km dt. This is going to be integrated from t to 0. Now this is going to be ln of st minus ln of so. It's going to equal negative V max T over Km. Okay. So now we're going to have ln of st, because we can combine these, divided by so, is going to equal negative V max T over Km. I'm going to raise this. So this is going to be e to the negative V max divided by Km T. And I'm going to multiply. So now we have st equals so e to the negative V max over Km T. Alright, so now we have this. So again, this is a hypothetical question, and what it was what would happen if the substrate concentration was this and the Km concentration was this. Okay. What that means is that we don't have V max. So from here we have to find our V max. I'd like to go back to this part to find my V max. I'm going to multiply this side by negative Km over T. So now I'm going to have Km over T ln st over so equals V max. Okay. So the first thing that they would give us they would give us some time point in here and some concentration of our product. Another thing that we have to know is that PT equals ST minus, or SO, sorry, ST. So our substrate at time 0 minus substrate at time. So they give us some sort of product. So you'd have to solve for ST equals SO minus PT. Okay. The point I'm getting at is when you're assuming two different things, you're going to have to do two different, very, very different ways of going about it. And you should know these assumptions. And what's also good is when they give you numbers like this, is you need to kind of know where to put these. So your Km obviously is going to go where your Km goes. The original substrate, which is 0.02 times 10 to the negative 7th, is going to be going into here. If they give you a product or some sort of substrate concentration at the very end, let's just imagine that they say after 1 minute, or let's just make it a little bit more difficult, 2 minutes, it will equal 0.02 times 10 to the negative 8th. So it's 1/10. So this is what your equation to find your Vmax would look like. 1.2 times 10 to the negative 4th divided by 2 ln of your substrate at 2 minutes. And I really hope that didn't freeze up. I don't know what happened to my screen. Give me one, please. Okay, I'm sorry about that, but here we go. It's going to be 10 times to the negative 7th. Sorry if you can't see this. This is going to equal your Vmax. We can take the Vmax and plug that back into this equation. Okay, and then we'd get our ST. You're able to solve any of these equations given any of this. And I just wanted to show you what would happen if your substrate was a lot less than your Km. Fortunately, your substrate for this equation, for this problem, is much greater than Km, making this very, very easy, and all you have to do is multiply it by the time. Okay, I hope part 2 didn't complicate you guys too much, but let me know if you guys have any other requests.